And today we're going to go over addition and subtraction of fractions. Probably pretty easy peasy for you guys, right? Okay, so in your notes, what does the denominator in a fraction represent? Cameron.
Like how much you have to get to go to the next one.
How much you have to get to go to the next whole number?
Like the 9 number is like had 9
Huh, okay. Okay, I think we're gonna maybe, so I see what you're trying to say. But isn't 9 nines one whole? 9 ninths? Okay. Owen, how many parts there are? It really names how many parts of something is divided up into. So the denominator names the number of fractional units or names the fraction. So go ahead and write that underneath denominator. Write that into your notes, please. Yeah, denominator. It's kind of hard to say on a Friday afternoon. So the denominator names the number of fractional units. So if the denominator names the number of fractional units, what is the numerator? What does the numerator do? What does it represent? Piper? Declan, what do you think? Yes, that's a great way to phrase that. The numerator tells us how many fractional units are in the fraction. So we're talking about 3/5. We're talking about 3 parts of a whole that's been divided up into 5 units. Okay, on the next slide, you guys have a couple helpful hints. And I put this into your notes because it helps to make sure that you are able to pick out of word problems where you should put fractions. So they are is, as, or are over of. And this is just when you have a word problem such as, let me think of an example. How many spokes of the tire are red? Let's say we have red and blue spokes on a bike tire or something, or bike wheel. How many spokes of the wheel are red? And let's say there are 3 spokes that are red and there are 20 spokes total. You would say 3 out of 20. Okay, so that would look like 3 20ths. More over than, we're going to come back to that one. That's going to be relevant a little bit later on. And change over original, also going to be a little bit more relevant later on, especially when we get to percentages. But today's notes, you don't want to lose. You don't want to lose this slide. This is going to be really helpful for you to go back to. So when you put it in your binder, maybe even put like a little, fold down the page or something that this slide is on so that you can find it easily in the future. Okay, so you can turn in your textbook if you want to, but I have it up on the screen for you, but it just looks a little bit nicer in your textbook. In the example on page 47, Maria's name contains 3 vowels and 2 consonants. So how many total letters does Maria's name contain? Dorothy? Good. It contains 5. Since her name is 5 letters long, 5 is going to be our denominator. That's going to name our fraction. Does that make sense so far? Because what I'm going to ask you is what fraction of her name is vowels? Do you guys see this of and is right here? You guys see that? And on that slide just above, I said is, as, are over of. Okay. So she has 3 vowels out of 5 letters. So 3/5 of the letters in her name are vowels. Does that make sense so far? See how I used the language in the word problem to set up my fraction? My is vowels. She has 3 vowels in her name. My of is 5 letters. She has 5 total letters in her name. That's a really easy one so that you can see that example. In the future, they might not be that easy. In Jake's name, 2 out of the 4 letters are vowels. So 2/4 or 1/2 of the letters in his name are vowels. All right, turn to the next slide. In your name, what fraction is vowels or are vowels out of total letters? Go ahead and write that down really quick. Mira, what's your fraction? Oh, you can do either. It doesn't matter. Rajveer. 3/7. Okay. Macy. Awesome. What happens when you simplify that? 4/6. Let's divide by 2. 2/2. 2/3. Good job. Olive. Good. 2/3. Okay. Carter. 1/3. Michael.
3/7.
Okay. Kylie. All right. What's mine? Do you guys know what my first name is? Yeah. What would it be, Lucy? What would it be? What's my fraction? 1/2 is right. Good. You guys even know how to spell my first name? That's you don't. It's Keri. All right. So we've got this and we've got this. So my fraction would be 1/2. All right, Ashlyn. Why is not a vowel, even though it sounds like a vowel sometimes? Okay, let's see if we can solve this puzzle. 2/3 of the letters in the name of this state are vowels. What is the state? So maybe start with 2/3 or, start with 4/6 or start with 8/12. So your state is going to have the same number of letters as that denominator. Could be 6ths, could be 1/3, could be 12ths. And there actually, I think, are a couple different ones that fit. See if you can solve that really quick. One works. All right, we've got 1, 2, 3, 4. 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. Does that simplify to 2/3?
Yeah. No, it doesn't.
It does not. 4/9 can't be simplified. All right, so not Tennessee. Do we have another one that we can try? Do we have another one we can try? It's gonna be 3/4. Landon. Let's try it. We've got 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7, 8. Nope, that doesn't work. Not Colorado. Morgan? I don't know. Let's try it. Alabama, 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7. Doesn't work. Oops, I meant to write a 7 there. Ashlyn. Okay, did you try it? Does it work? 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7. Nope, not quite. Not quite. There are at least 2 solutions. Cameron. Let's see if California works. I don't think it does. 1, 2, 3, 4, 5. out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Nope. California doesn't work. All right, last one. We're gonna do one more guess, and we got to move on. Zaya,
Is it Florida?
I don't think so. It's probably somewhere where everyone wants to go.
Hawaii.
Hawaii works. That's, Hawaii works. 1, 2, 3, 4. 4 over 6. Check. There's one more. It was Louisiana. That was the one I was just gonna say next. I was just gonna say that. Yeah, okay. All right, let's bring it back. We got a lot of ground to cover today. I need you guys to open up your textbook to page 48. Okay. Davio ate 1/4 of a pizza. Ethan ate 1/3 of the same pizza. What fraction of the pizza did they eat together? We all should have our textbooks open to page 48. All right, here's Davio's. And where's Ethan's? Here's Ethan's. Oh, Ethan's isn't listed there. That's okay. If we're going to add fractions, we need to have, what do we need to have? Rajveer, go ahead and write that down. Good job. Common denominators means parts that are equal size. All right. Right here, we've got a pie, a pizza that's divided up into 1/4 right here and 1/3 right here. Are those equal sized? No, they definitely aren't. Let's take our third down here. If I split each one of these thirds into halves, how many parts of my pizza do I have? How many parts of my pizza do I have now? No, total. What's my pizza divided up into? Mendel? Yeah, it's divided up into 6, and that means that Davio ate 2/6, right? If I do the same up here and I take my quarters and I divided those up into half, how many pieces is my pizza now divided up into? Kylie? Yeah, and how many portions did Ethan eat? Let's see. Oh, I got my people mixed up here. I'm sorry. Oh, Davio was the one who ate the 4ths and Ethan ate the 3rds. Davio ate 2/8 of the pizza. All right, well, do I have pieces that are the same size yet? No, I sure don't. I can't add 2/8 and 2/6 together. What if I divide my 4ths up? What if I divide each 4th up into thirds? Like this. Now, how many pieces of pizza do I have? Lucy Cole? And how many did Davio eat? Yeah, he ate 3 out of 12. And then I go down here and I divide my thirds up into 4ths. How many pieces of pizza do I have down here now? No, total. I have 12 pieces of pizza down here. How many did Ethan eat? Owen? Actually, I think he ate 4 12s. Thank you. Okay, can we add these up together now? Yes or no? I can add them up together. So I've got Davio's pizza up here. I can add Ethan's pizza right here. Okay. Okay, well, sorry, buddy, I'm not able to gather homework for you right now, but if you want to take home what you see up here for the rest of the day, like your science and history binder, so you can do, and maybe your literature book, so you can follow plan book and make up those lessons, and do that. Okay. Okay. That's fine. I have to continue with what I'm doing though right now. So you're on your own there. All right. Can I add 3/12 plus 4/12? Yeah, Rajveer, how many did they eat altogether? 7/12, exactly. All right, so let me skip forward here a little bit. So 1/4 plus 1/3 equals 3/12 plus 4/12. I'm on the next slide now, you guys. And 3/12 plus 4/12 equals 7/12. Okay. Let's go to the next one. Does everybody have that down? Yeah? That makes sense to everybody? Okay, I'll pause on that for just a second. All right, let's take a look at the next one. There were some students in a summer class. 2/3 of the students went to the museum and 1/4 of the students went to the zoo. The rest of them remained in the school. What fraction of the students went for a class trip? Well, let's deal with the people that went to the museum first. All right, we're going to label this one museum. All right, how many of the students went to the museum? McKinley? Okay, let's divide this bar up into 3 parts. And to divide up into, whenever I'm dividing up a bar model into an odd number, you guys, I am going to kind of divide slightly off center. So I'm going to do my first 2 units like, actually, I don't feel like that one was very good. I'm going to divide like right about here. For thirds, I'm going to do that. And then I'm going to divide my next third over here. I'm still not happy with that. I'm going to make that a little bit neater. Okay, how does that look? That's pretty good. All right. 2/3 of the students went to the museum. So let's shade the portion of the students that went to the museum. And 2 units out of 3 went to the museum. Okay, let's go to the next piece of information we have. 1/4 of the students went to the zoo. This is going to represent my number of students that went to the zoo. So I'm going to divide this up into fourths. So I start by dividing my bar model in half, and then I'm going to divide it in half again. And that's going to give me really nice, even units. It's really important that you guys think about this. What I don't want to see happen is, is for you guys to approach a bar model like this, where if you're dividing it up into 4, you're going 1, 2, 3, oh, and then we've got 4. Because that does something, right? Your brain is looking at that bar model, and is your brain thinking that those units are even or are the same size? Uzziah, what do you think?
It makes me think it's like, I feel like filling it is like 1/2.
Yeah, exactly. It looks to me like this is 1/2 of it, but it's really just supposed to be 1/4, right? So yeah, so we're going to really strive for neatness and regularity with our fractional bar models, you guys. We really want to work like that. All right. So we've got, how many of the students went to the zoo? We've got 1 of those 4 units going to the zoo. The rest of them remain in the school. All right. So what I want to know now is how many kids went for a class trip. I'm not how many, but what fraction of the students went for a class trip. So we're going to kind of try to add these together and make a new bar model that shows how many students left. Can I add 2/3 and 1/4 very easily? No, Rajveer, what do you suggest we do? Let's convert the fractions to 12s. I really like that idea. All right, so we've got 2/3. And to convert to 12s, we're going to need to multiply our thirds by 4/4, right? So we're going to have 8/12. So let's take a moment. And since we're multiplying by 4/4, let's go ahead and change our bar model. So that means we're dividing all of these thirds into 4 sections each. This is where neatness really helps. And now we have 12ths. All right, what do I multiply? What do I need to do with the this next bar model? I have 1/4. What should I multiply it by to get 12ths? Mira? Yeah, we're gonna multiply it by 3/3, and we're gonna get 3/12ths. And let's make sure that we reflect that in our bar model. Okay, so I'm gonna divide each of these sections up into 3. Can you guys see what's happening right here? These units are beginning to look like a similar size. I mean, I'm freehanding these, so they're not perfect, but they're pretty close, aren't they? Okay, so let's go ahead and make a new bar model down here. And we're gonna divide this up at the 12ths. And we're gonna use this to show all of the kids that went on a class trip on this day. Okay, so I've got my 8/12ths that went to the museum. So let's shade in the first, oops, I want a highlighter on this one. Let's shade in our first 8 units. For the museum. And then we're gonna shade in our next 3 that went to the zoo. Now, how many units do I have left on here? Looking at this is my total down here. Looking at the bottom bar model. Morgan? Yeah, I just have 1 unit left, and that represents the students that remained in the school, right? So that's actually that's not my question though. We want to know what fraction of the students went for a class trip. So what I did right there was I added 8/12ths and 3/12ths. And what did I end up with? Yeah, and can we see that in our bar model? Yeah, we got it, right? Okay. So there are a couple ways to do this. Are we good to move on, guys? We can, one, find the lowest common denominator, or sometimes we might choose to find a larger common multiple. Okay, so let's just demonstrate this with a word problem. It says Christine has 4/5 of a meter of red ribbon. She needs a blue ribbon that is 1/2 meter longer than the red ribbon. Find the length of the blue ribbon. All right. So method 1 is to just find the least common multiple. That's what method 1 is there for your notes. Just write least common multiple next to method 1, or LCM for short. Are you guys gonna know what that stands for? Least common multiple, LCM. All right, so we've got 4/5 and we've got 1/2. What's the least common multiple between fifths and halves, do you think? We know that 5s have multiples of 5, 5, 10, 15, 20, 25, and so on. And 2s are multiples are all even numbers. So what do you think the least common multiple would be? Lucy Cole? Yeah, it would be tenths, right? So what we're gonna do is we're gonna multiply that. Let me do this by hand. I don't like the way my animations look fast. We're gonna multiply 4/5 by 2/2. And we're gonna get 8/10. And we're gonna multiply 1/2 times what to get tenths? What do we have to multiply 1/2 to get to tenths? Michael? 5/5. Good job. And we're gonna get to 5/10. Can we add these now? Yep. So let's go ahead and add them. We've got 8/10 plus 5/10. Let's make my 8 look a little bit nicer there. And that's going to equal 13/10. Now what? Piper?
13/10 is, I forgot what it was called, but it's not simplified.
Yeah, it's an improper fraction. Yeah, good.
improper fraction.
Uh-huh.
So you would, make it 1 and 3.
We would make it 1 and 3/10. Good job. Okay. Pretty It's pretty much a review, right, folks? Michael, do you have a question or a comment? Okay, I'm gonna have you save it because we're running short on time unless it's like really. Okay, Lucy?
How do we get to?
This is 4/5. Did, right here, is that what you're looking at? No, that's just my hand. That's just, it's really hard to write with the stylus sometimes and yeah. Sorry about that. All right, so that's one way. We can find the least common multiple. That's usually going to be the best way. That's the way I definitely prefer for you to do it. Have we all written something to this effect right now on method 1, least common multiple? If you haven't, write it down right now. Find the least common multiple. Okay? Just write LCM, least common multiple. Because we kind of got to rock and roll. Method 2 is to use a larger common multiple. What's another multiple of 4/5 and 1/2? What would be a larger common multiple? Mira?
100.
Sure, we could do 100. I'm going to use 20ths. It's a little bit easier for me. So let's use 20ths and just demonstrate. All right, same problem. What do I need to multiply 5ths by to get to 20ths? Owen? Yep. So then we're going to have 16 20ths. What do I need to multiply halves by to get to 20ths? What do I multiply halves by? Macy? 10 tenths. Good job. So I would have 10 20ths. So now I can add 16 20ths and 10 20ths. And that's going to give me 26 20ths, which is going to equal 1 and 6 20ths. Can you guys see an extra step now that's going to need to be taken? Rajveer, what do I need to do? Yeah, I'm going to need to simplify. And so that's why I prefer to use the first method, because usually using the least common multiple is probably gonna, it might save you the step of simplifying. Sometimes it doesn't, but it probably will. All right, so the blue ribbon is still 1 3/10 of a meter long. So method 2 is just use a larger common multiple. Either one of those is fine, but you're always going to simplify in the end. Yikes. We are running short here. Okay, let's skip ahead a little bit, you guys. We're going to skip to number 4 in your notes. The one about Mrs. Ding baking a cake. She's baking a cake. Okay. Oh, wait, is that the one that I want to do? Yes. No, that's not the one I want to do. I take it back. I want to do. I want to do number 3. Okay, because we need to do some subtraction here. All right, number 3. Mary has a blue ribbon that is 1 2/3 meters long. She has a red ribbon that is 1 3/5 meters long. How much longer is the blue ribbon than the red ribbon? Can you guys, this is going to be a subtraction problem here. All right, we need to also find a common denominator if we're going to perform subtraction. Usually finding the least common multiple is the best method here too. So let's go ahead and set this up. What is a common denominator of 3 and 5, thirds and fifths? What would be my least common multiple? Ashlyn G? Morgan? Yeah, it would be 15ths. So let's go ahead and multiply that 2/3 times 5/5. And we're going to get 1 10/15. And then let's multiply 1 3/5 times 3/3. And we're going to get 1 9/15. Alrighty, help me set this up. We are subtracting the red ribbon from the blue ribbon. Which number comes first, 1 10/15 or 1 9/15? Olive? Yeah, is it because it's bigger? No, it's not because it's bigger. That was a trick question. Because you know what is going to happen, you guys, really soon is you guys are going to be subtracting a bigger number from a smaller number and you're going to end up with negatives. No, it's it's that way because we know from the word problem that we want to find the difference between the red ribbon and the blue ribbon, and the blue ribbon is longer. Not necessarily, just for that other reason. Okay, but 1 and 10/15 minus 1 and 9/15. All right, 1 minus 1 is what, class? 0. Okay, so we don't need to deal with the ones. What's 10 minus 9? So how many 15ths of a meter is it? 1/15 of a meter. Okay, good. All right, let's turn to I want to do one more subtraction problem. Let's go to your exit ticket, and I'm just going to have you write one down. Okay. I would like you to do these two problems. A, 1/4 plus 1/3. And then secondly, I'd like you to do 2/3 minus 3/5. I want you to tell me, you do letter A. Tell me what you converted to though. Okay, so then what did your problem look like? Three 12s plus 4 12s, which equals 7 12s. Ooh, I'm losing power. I think it's about to go off. All right, how about B, really fast before my computer turns off? The real Macy in the house. Go ahead.
Well, what is frozen?
Oh, it's frozen. Okay. Whoops. Sorry about that. All right, go ahead.
So I converted.
Okay.
So.
Okay, so you had 10/15 minus 9/15, and you got 1/15. Great job. All right, your homework tonight is workbook exercise 1.